Hey guys, this is Miss Samra. I'm back with my next lesson. So today I have 8-3 and it's the same section still. So I'll be showing you a few more examples on U-substitution. I have example 7 and example 8 on page number 534 if you want to follow along. So you can go to page 534. And first I'll start off with example number 7. Example number 7. Okay, so the equation is y is equal to integral of 1 over x times ln x and its dx. Okay, now this problem is slightly different than the one we did before. This one already has ln function in it. So it means I already know just because this has ln function in it, so this is definitely going to be log function once I integrate that function. Okay, I have ln in it. You can still do pattern recognition for this, but I'm going to show you U-substitution just to give you kind of another perspective of this problem. So basically, anytime you have ln function involved in the problem, in the equation already, so the way we do is just set that ln function, set it equal to u. And rest pretty much it's U-substitution. You know every single term you need to replace in terms of u. So what I would do is I'm going to take derivative of this equation first. So let's do that. So derivative of u du over dx, derivative of ln would be 1 over x. Now let's do cross product. So du would be equal to, or how about if I just say 1 over x and times it by dx, because what I did, I just multiplied both sides by dx. That's what I did. I can still simplify more, but I'm just going to leave it like this. Depends on what I need, then I'll just simplify more. Okay, back to my original equation. So it's integral. I have 1 over x. Let me just split up, and that way, again, it's easier if you split up every single thing. Okay, now I have these 3 different pieces I have to replace with in terms of u. So 1 over ln x, which that's going to be 1 over u. I still have 1 over x and dx need to replace. So if you look at carefully, isn't it 1 over x and dx is equal to du? All right, so I'll bring in du. Now let's integrate the function. I have 1 over a function, which is definitely going to be log function. So let's integrate this function. So this is going to be ln of u, and I would add c at the end. Almost there, just one more step. So time to replace this u with x, or original function. So what is u equal to? So ln would stay the same. Oh, don't forget you need absolute value because it's the log function. And for u, I would replace ln x, and there's a c at the end. Here you go. So that would be my answer. Okay, again, I repeat, anytime the original equation already has log function in it, just take that log expression, set it equal to u, and then just do U-substitution for the rest of the problem. Okay, another example, example number 8, and it's still on page number 534. I have 1 over radical x plus 1 and integral and dx. Again, this looks exactly like normal problem. So how would you know it's log function or not? Remember, there's a way you can check. So let's just take this whole expression to the top. Let's see what happens. Radical x plus 1, and this would become -1. And later on, if I do the normal process, if I add and divide by that, isn't it that would make this function undefined? So this is going to be log function. How do we do it? I'm going to show you with U-substitution. I'm sorry, the text kept bothering me. My bad. I'm sorry. So let's do U-substitution for a problem like this. For something like this, you have 2 different ways you can actually set an expression equal to u. Either you can take this whole expression in parentheses and set it equal to u, or you could just take the radical part and set it equal to u. All right. As long as you take a radical with x and set it equal to u, yes, that's totally fine. You cannot make x equal to 0 because that would not make any difference to that equation. All right. So let's say, okay, again, you could do either ways. You could do radical x plus 1 equal to u, or you could just take the radical part, set it equal to u. I'm just going to take radical x, and let me just write it other way. It's easier. So let's say I have u and it's equal to radical x. Okay, just like always, let's find the derivative first. So I would do du over dx, derivative, you can rewrite. This becomes 1/2, and it would be x to the negative 1/2, which later on would become this. I hope this makes sense. Because isn't it, you need to take away 1? It would become negative 1/2, and I already moved it to the bottom and then made positive. Okay, that's just the derivative. But again, still, I'm going to simplify more just in case. So let's do cross product, or let's just multiply by dx both sides. Or you can do cross product either ways. So I would have du, and it's equal to 1 over 2 radical x, and it's equal to dx. Again, if you want to do cross product, you could do that. So let's just say multiply by 2 radical x both sides. Or you can just do cross product here, either ways. So after cross product, it would look something like this. I'm just going to stop here. And later, I'll simplify more if I needed to. And one more thing I would do, I already know u is equal to this equation. I already know it's actually, yeah, that's right. So dx is equal to this whole equation. So, okay, let's see what we need for this equation. Back to this integral. I have 1 over, so as you know, radical x is equal to u. So I would replace that with u. Plus 1 would stay the same. What is dx equals to? Now let's look that up. Oh, yeah, dx is equal to 2 radical x and du. Okay, now here's the thing. I still see this expression in terms of x. You still have to replace that. So if you look back to this equation, isn't it radical x is equal to u? So let's do that. So I would replace, okay, I have 1 over u plus 1. I have 2u, and it's du. Here you go. Finally, everything is in terms of u. Let's put everything together. So how about if I factor out the constant, and my new equation would look something like this. Okay, almost there. Now, I can't split up into multiple fractions because the denominator expression is not just one term. If it is, yeah, you could do that. Multiple terms, you can. But now, try recalling day before yesterday's lesson. If you have same degree or the top degree is bigger than the bottom one, we do long division because you need to rewrite this. How do we rewrite it? So we need to do long division. So let's divide. Divide u by u plus 1. So u times what makes u? It's 1. So I would multiply this whole expression by 1. It becomes u plus 1. Time to switch signs. If I switch sign, oh gosh, red, negative and negative, cancel these out. So I have negative 1 left. So let's rewrite this. So 2 would stay outside. Remember, I always put it in brackets. It's easier because this 2 belongs to every single thing. So I would have 1 minus 1 over u plus 1. Now, the reason I put minus because, you know, later on the plus one here would get simplified with negative, so it's still going to be that. Let me just put integral on both. Now, rest is just integrating every single function. 2 would stay outside. Integral of just a constant would be u. Okay, now try understanding. We're not dealing with x's anymore. So if it's a constant, it would give you u, not x. All right, don't forget. Minus, I have 1 over an expression, this whole expression. I hope you remember. If it's 1 over something, you know it's going to be a ln function. Make sure it completes the pattern. The derivative of u would be 1, which this already has it. So it means I would just say it's ln of u plus 1. And I'm just going to add c outside. Okay, almost there. Now, time to bring back the original function. What's u equal to? U is radical x ln radical x plus 1, and I'll close parentheses and c at the end. If you want to distribute this too, you could do that, or you could leave it like this. Either ways, it's going to be the same thing. And yeah, this is pretty much all. So if you have any question, just send me a comment. I'll answer that question. Thank you guys. Stay safe. Bye-bye.